Okay, where to start? So welcome to the stream. Or I guess most will be seeing this on YouTube. This is part two of potentially part three of three parts of figuring out how to do turning this 3D plotter, 3D printer behind me into a 2D plotter. I've been wrestling with this Raspberry Pi webcam back here for the last 10 minutes so that I can maybe get a little screen here that we could see in sort of real time until I can actually get a better webcam to set up back there. So at this point, we can now kind of see what's going on in real time instead of me having to just point like I was doing last time. So slow improvements with the stream as we go forward. So yeah, so let's catch up where we left off last time. So last time we started the video where I kind of said how I made this whole setup here. The little adapter that connects the pen to the 3D printer, and we went through SolidWorks with that. And then the intro to how I discovered the code to make this box. And then we actually started writing some of our own code to make the alphabet. And we left off with having drawn the numbers 1 and 2. And so today, hoping to finish up the remainder of the numbers in the alphabet. Yeah, so let's start with VS Code. I remember writing a to-do before we left. So here's our to-do. Write everything to a file so I don't have to manually copy the output from the terminal into a G-code file, which we have here. Clean up our Python code so our output doesn't look as messy and confusing to read, which actually is kind of legible, so we might just leave this. So let's move that to the bottom for now. Finish with the numbers and letters. Add support for doing new lines, so say someone gets to the end of a line and they want to keep writing, figure out how to get it to the next line. So I've been having some thoughts. So let's quickly jump into the code and what we had last time. So this is just some Python code. I guess we should start with the main bit. So this is our function, our main function that kind of sets everything up. And here's a bunch of config parameters, which we discussed last time. And the magic kind of happens down here. So for each letter, so right here we're passing 1, 2, 3 into our main function. And so for each letter in that string, we want to print it out. And then once we print it out, we kind of want to move along the X direction after we finish a letter. And we discussed this last time in the video as well. So we look at this character map. This is kind of where I've been thinking, and I kind of want to add some some refactoring before we jump in. So characters are made of kind of this bit excessive, bit verbose set of functions. And sorry, I'm going to clear my throat a lot today. You'll notice a lot in these functions that there's a lot of repetition. So scale factor, travel height, draw height, X start, Y start, all gets fed down into each of these lines. And that's just like a lot of text. And I have this dream of a function where we don't even have these. And the char map, the character map, just looks something like where we say like, let's split this out. So the number 1, we're moving primitives B and C. And so instead of having all this junk here, we could just say character map 1 is just BC, or maybe to make it a little bit more legible, we could go like BC, and these are the steps that make up the number 1. And then somewhere we have a function which takes care of kind of mapping this letter B to that primitive. So that's kind of where I think I want to start off today, because this was excessive and kind of confusing to do. And so much easier to troubleshoot up to 7 letters. And as a quick tangent for those that don't know what we're talking about, we're using the 7-segment alphabet. And this is kind of what the 7-segment alphabet looks like. It's an ability to, within 7 lines, get the entire alphabet. And it's kind of ugly, but for the purposes of this project, I think it's sufficient. And then a 7-segment LED is broken down into 7 parts: A, B, C, D, E, F, and G, and that's the letters that we've been using throughout the code. So character 1 is B and C. So if we come here, we see that B and C, and that's a vertical line, gives us the number 1. Cool. So I'm going to leave that open because I'm definitely going to be referencing that today. All right. So to refactor, to end up with something like this. So let's comment this out. Let's say our character map. So 1 goes to BC. Looking on the right side. You know what? Let's get wild. Let's just do this. 2 goes to A, B, G, E, D. 3 goes to A, B, G, C, D. Cool. All right. So now we want a function that kind of replicates all of this. So maybe draw character. And that will take in the character to draw. And so if we start with 1, so we'll say primitives equals character map of character to draw. So primitives will now be, for the number 1, will be BC. And then, so for each of those primitives, we're going to need to draw them. And so now this is kind of where the other magic happens. So let's see, we have to make a draw primitive function. And that will, could probably be one of these maps. Line A, B, C, D, G, and all that. So if we do a primitive map, I feel like there's going to be some more factoring. I'm kind of solving this as I'm coding. So A will go to line A. And if we just repeat that twice, let's see, actually let's just look at 1 for now. So 1 needs B and C. Don't want to type if our solution's bad, you know? Don't type too much. Okay. So draw primitive, we'll take the primitive. So in this case, it'll first be B, and draw primitive will be, let's call that letter. These could be better named. Okay, so actually we might not even need this function. Thinking we can just use this dictionary, and we'll say output equals this. So draw primitive, we don't need this. We would just need output plus equal primitive map of primitive. Cool. And if we turn that out, okay, interesting. So not quite how this functions. So we need to get scale factor and all these things into character to draw. Cool. And then if we take all these, so this is actually a function, so we can't do this yet. So we have our function there, and then we could then call that So this will get, let's see how this will work. So this will get the letter B first. Letter B will look up and will give us this function line B. And so this is a function. And then we want to call that function with all these parameters that we have over here. So this is actually line B. And then the output of this, so we go over to primitives. The output of line B will just be this code, or sorry, this string with these bits in there. Cool. So, so if we do that, refactor, draw character should now take the character. Let's rename these for consistency. Cool. What are the chances that we can draw the number 1? Because I know if I leave 2 and 3 in there right now, it's going to throw an error because we only wrote this up for the number 1. All right. Character map is not defined. Line 24. Huh. This should not be a string for 1. Might that be it? No. Still an error. Oh, man. Because that's an equals. Okay. There we go. Huh. Sick. All right. So to sanity check that, let's actually save this to a file. And then we'll knock that other task down. Actually, let's not get focus on one thing at once, even though I want to do all the things. Because just indent this and then knock out another one of the tasks I want to do today. But we're not going to do that. One at a time. Okay, cool. So that code is saved. Let's go ahead and upload. Where's my desktop? There it is. Cool. So we have no pen on there right now. I just want to see that in this video. It just draws a straight line. Oh man, this video does not want to respond. Well, apologies. I thought this would be cool, but it's totally just not responding. Okay. Let's try that again. Just gotta get rid of that dramatic Z drop that we had in last time. Oh, just kidding. Okay. Okay. Well, if y'all could see that in real time, I'll figure that out for next time. But anyway, it is what we wanted to do. Draws the number 1. So let's commit this because this is at a good point. Draw the number 1. Cool. All right. So I think all this is actually useless now. I do like this bit because we have lost the little comment that says that this is 3. So if we start the output as an F string, throw in character to draw, save that, run it again, we now get that little comment back. Sick. And now we don't have to hard code any of this, which means we can delete this code. Boom! Awesome. Which means we don't need this, which means characters. Oh no, that was not what we wanted. Okay, cool. Let's clean up. So we want to keep our primitives. Actually, a little confused. I didn't import line B and C, but it still executed B and C, or not. How did this execute? Will this run if I delete this? Line B is not defined. Okay, let's... I've been programming for years, and Python imports still baffle me. So if we open up characters... Oh, that's awful. All right, so what I'm noticing here is that I... Why? Why is this a thing? Okay, so line B comes from the primitive style, but we're not importing primitives. We are importing characters. So if we go over to characters, we realize in there we are importing primitives. So when you import star, it just brings everything with it, including all of these primitives. Okay, don't like that. Let's stop using star imports. Okay, cool. So now we can delete characters.py, and primitive should still work. Cool. Okay. Get rid of this code we don't need anymore. All right, let's finish out our primitive map. B, D, E, F. Cool. Okay, so we have 1, 2, 3 drawn out. Let's see if that still does 1, 2, and 3. Sweet. So we've done a nice little refactor, gotten rid of the entire characters file, and our primitives are a lot nicer. I feel like there's a bit of repetition that could be gotten rid of, but I kind of like these as atomic little functions, so we'll leave that be for now. Basically, what I'm referring to is the fact that we have so many arguments repeated. But at least for now, I don't see us repeating those, unless we wanted to do stuff like make bold text or italic. I don't know if italic text would even... Oh, italic text could totally be done with this. Let's stay focused. Let's do a little pipe dreams to do. Cool. So, haven't done any of these. But I was reading Adam Savage's book, and he talks about when you do things and you forgot to add on your to-do list, add them on anyway after the fact. Makes you feel good about finishing things. So refactor to not rely commit. So now at this point, mapping the rest of them is just a matter of looking at our 7-segment bit, typing them all in without making any errors. So 4. This is going to be a bit tedious to watch, but let's see if I can do that. Oh gosh. Not used my keyboard shortcuts on Windows because I don't code on Windows. There we go. Okay. 4, 5, 6, 7, 8, 9. This should be moved to its own file. STUVWX. Oop, YZ. Cool. All right. So if we open this, get rid of that, put that there, put that down there. We can now kind of go through and manually do this. So 4 is F, G, B, 5 is A, F, G, C, D. 6 is 6 is A, F, G, C. 7 is A, B, C. 8 is everything. A, B, C, D, E, F, G. 9 is all of them minus F. Or E. Yeah. 0 is A, B, C, D, F. A. Guess we don't get capitals and lowers, but the joys of a 7-segment. All right, B is F, E, G, C, D. C is A, F, E, D. Ooh, this is tedious. E is A, F, G, D. F is A, F, G, D. G is A, F, E, D, C. 8. All right, I'm gonna stop speaking. K is gross. K is a gross letter. Stretching with the M. Okay, taking a quick tangent. Let's bring up a calculator because I'm curious how many. Go make it big. Can we just type this? 2 to the power 7. Nope. What? I don't want an XOR. Oh, let's just do this in code. Cool. So each of these segments, 1, 2, 3, 4, 5, 6, 7, 7 segments, can have an on or an off. So that would be 2 to the power 7th. I'm curious how many different characters you can get. So you can get 128 different variations, and we've used up, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 by 4, 64. So half of all potential characters you could make on this segment. I guess we're repeating because O and 0 are the same. Interesting. Cool. So anyway, off the tangent, letter Q looks like the number 9. Yeah, there's definitely some repetition here. T. Oh, that's actually not bad. U is F, E, D, C, P. Oh, V is terrible. X looks like the letter. Ah, interesting. Okay. I know I'm totally going to plot this all out and go, that's an error. And then I'm going to look at the alphabet and go, oh, it's not. That's as intended. Like the Z. What? You'd think that's an error, but it's not. And I'm totally going to type it wrong because there's no E. Interesting. All right. We should add that eighth little bit. So we'll leave that as a to-do for later. How does one do a comma? One does not do a comma. Well, they do. Interesting. Okay, so we can add those actually in. Give a little bit of spice to our... let's see, which characters do we want? Let's take the dash, which is G. And take an underscore. Just kidding. I want a space. I think space would be helpful. What would a space be? Just nothing? Okay, so let's see. How would this code work if we got a space? So the character to draw, it would print out the character, and it would come in here. So for X in an empty string, what does it? Let's see, letter is... Okay, so it doesn't print out at all. So this function, since character to draw is just an empty string, the output would be, I guess, a space. It would just be that space. Let's see what that looks like. So let's split terminals. It's not the terminal I wanted to run it in. Try this again. Oh, probably missing a comma somewhere. Yep. Cool. Alright, so we should expect... What's that? Yeah. Yep, there's a space. Cool. Alright, is it time to test? Oh, man. How do we want to test? Primitives are currently 20 millimeters high and 10 millimeters wide. So to print the alphabet would be 36 by 10. Oh, that's really large. That'd be too large for my printer. So to do a full test, I think we need to do figure out new lines. But one other thought. We want to do a little bit of error checking. So if I type this right now, this is going to fail because if we come into Python, so like say we have the letter H. Is H equal to H? Yes, that makes sense. Is H equal to capital H? No. I think this is a function in Python. Yes, so lower letter H is equal to capital H but lowered. So when we take our input string, so we're going to do that. and that'll lower it. We also maybe want to check. We don't want this printer because this printer is going to start going through. And so say we had like hello world exclamation point, and we know we haven't added support for exclamation points yet. So it's going to handle this just fine, and then it's going to start plotting, and maybe we have a long plotting job going. We want to write out the text of, I don't know, a book or something. It's going to get all the way here and then fail. So if we want to get, should be another to do. Should go right here. Because this feels a little bit more involved. Cause printer do not start if illegal. Cool. Okay, so let's leave that for now. Oh, this might actually not be that hard. I might just do that right now because I'm going to be a little bit annoyed if I introduce characters I shouldn't have. So if we do this, and we do character map, dot keys, so that gives us a dict, and if we want to turn that into a set, cool. A set, for those that don't know, is just a collection of unique characters or unique things given an input. So if we do a set of A, B, C, although my there, yeah, because it's not a list. Okay, so once a list is an input, oh my gosh. So there's our set. And that makes sense because A, B, and C are all unique. But what if we had another A in there? It's the same output. So it'll take duplicating things and delete them. So we really just want to do a set on the input. So if we do a set of hello world as an array, hello world, we want to split that by each letter to turn it into an array, and then we take the set of that, and also we want to lower it first. Lower. Oh, this goes there. Empty separator not allowed. What? That's what I just did. Is there an extra? Oh, that's, oh gosh, this JavaScript documentation. That's why I thought that would work. No, just give me, yes. Yeah, that's not what I want to. Useless. Okay, cool. There we go. Yes. Alright, I guess that's what I'm using. Alright, so if we do, so we say hello world, and then this is our input, and then if we set on our input, we'll get the unique characters that make up my phrase. Cool. Okay. So sanitized input is now going to become a set. Can you iterate on a set? Sweet. Okay, so you can iterate. So okay, so this will, for each character in the input string, lower it, and then turn it into an array, and then we want to take a set of it to get the unique keys of it. We don't want to quite do that, so sanitize input. will give us what we need to print out, but then we also want to do some checking. So I forget. Let's see. So this is my set. There's a way to do intersections, which I forget. Okay, so my set intersection. So we call set on. Okay, so if I did this correctly, I believe this should just return W and D because my first set has W and D but doesn't have the letter A. Sick. Okay. So almost there. So if we do if I think there's the opposite. There's another method, intersection, of things that like shouldn't be in there. Set methods. Okay, what do we got? Difference. Returning a set containing the difference between two or more sets. Okay. So if we do instead of intersection, do difference, I think this should return A and then all these letters after. Doesn't return A. Oh, it returns everything that is the same. That doesn't make any sense. Oh, is subset. That makes sense. So okay, and then if I remove, hopefully this returns true? Nope. I think if we do it backwards though. Is subset of my set. This should return true. Okay, and then if I add an A here, it should return false. Cool. So this is saying that W and D are both in my set, but A is not. And that's what's returning false. So if set of the sanitized input is a subset of the character map.keys. Ooh, where did that go? And then we need to turn this into a set. And we want to do if not that. And we want to raise an error. Invalid character supplied. Be nice if we could figure out which ones they are. I thought difference would be it. So we do difference. Oh, it does. That's weird. And then I guess, can we join... I hope this is not JavaScript syntax. Cool. Okay. So we can say which characters are not correct. So if we do... set of my sanitized input difference comma join. Okay, this should give us an error. Cool. Okay, so if I call this with hello world, it should work, or it should fail. Do I have too many parens? I do. Nope. So let's do input set equals this. it's a little bit more legible with all the parens we got going on. Okay, so if the input character set is not a subset of the valid character set, invalid characters would be the invalid set, and the difference between that. Okay, and that should work. Oh, that shouldn't be there. Okay, that's what I was complaining about. Unmatched f string, because we are using single quotes everywhere, and we need to close out because the inner point. There, come on, there we go. Okay, sweet. Okay, and then now if we run it again, it should tell us that exclamation point is not supported. String object has no attribute invalid characters. That is correct. Boop. Let's get that period in there. Cool. Exception must derive from base exception. Raise should that letter F is from JavaScript. This is what I get for context switching. Cool. Invalid characters supplied, exclamation point. Take it out, save it. It works. Cool. So that is done. All right. Cool. So I guess this is our output actually. And those look like world, W-O-R-L-D. I was reading through some G code the other day for my 3D planner just to kind of understand it, and I like this kind of like, this is the letter L, and this is the letter L, and then this is the letter O. It's a little bit more legible. So I think I'm actually going to come in here and get rid of the tabs and move that task down. Cool. Finish numbers and letters is sort of done. So I think the next two tasks want to write to the file and then support new lines. So to write to file, we have to get rid of all mentions of print. 1, 2, 3, 4, 5, 6. Cool. And this doesn't need to be in here. Kind of like layers of abstraction. Like, this is our main function. It does all the heavy lifting. It doesn't. Kind of to keep this sane, we're going to refactor real quick. So really all I want to do is validate input. And none of this is actually needed to make this function run, so we can cut it out. Make a new imp function. And then we can just call that with the input string. Cool. And so this function will get run with the sanitized input. Cool. And that should still work. Cool. And then if I pass in hello world, an exclamation point, it'll fail. Okay, so that still works. So refactored validation into own function. Cool. Okay, so now to get rid of these prints. These almost feel like these don't belong in here either, but this main function at this point is only, what, 20 lines long, so. Continuing with our convention that we had before of outputs, where's my tab going? It's going to the other file, because I'm in the wrong thing. Okay, now I'm back in the file. So as our convention has been going, we're going to use output equals, start with an empty string, and then build that up. So output plus equals that, and then output plus equals this. Cool. All right, so don't actually want to return this out. We want to save it to files with open output.gcode. I believe that's W mode to write. So that's f dot. This is the first time guessing how to do this function, but I think that's it. Let's find out. Huh? Did I get it? Sweet. Okay, so no new lines there. So dash n, let's add a new line. Let's add a new line. New line. Cool. So that should just override the previous file, give us some new lines. Cool. G28 is indented weirdly. Whatever, it's not that important. Actually, all these are indented. All of these except for that one are indented one extra level. I bet you if we add in a new line here, it'll resolve itself. Sick. Looks like some G code. All right. I do kind of want to not override my G code. It would be nice to be able to see them kind of progressing as we go. So instead of just output, it's like output 1, output 2, output 3. Which I think most easily could just be solved with the timestamp. So let's do that. And the output changes to an F string. Datetime.now. Oh gosh. I think if I just wrap this in string, it'll work. Nope. Invalid argument. That makes sense. That makes sense. Actually, before we do that, let's paste our G code in. Let's see if that works. No. Part of this is an invalid file name. I think it's the dots, and we don't really need the milliseconds. I think it's string from time. Yeah. Return to string representing the date, controlled by analytic format string. Okay, so the format. Okay, here we go. So where are all the write-ups of these characters? There we go. Cool. Okay. So we don't really care about year, hours, 24. Okay, so the format is percent year. Month. Month is 0 padded. works. Month, and then we want day, percent day. And then hours, 24 is fine. How about minutes? Minutes. Hours, minutes. Let's go seconds. Percent S. Okay. Running that should work. No type. Oh, I'm totally using that. Oh, nope, that's not what I want. Okay. So, we actually don't want to do it like this. Do this. I don't know if it's on the daytime. Or actually, sorry, I'm doing this. Daytime.now. I think that's how you do it. Okay. Sick. Okay, so 2:20. Today is 5:2. It is 1:51. 41 seconds. Cool, cool, cool. Okay. Lastly, I want to update this to not save all of these into Git. Maybe add a little folder called G-code. And then we can save that there. Cool. Okay, so we can clean up all this. Also, I don't know what this crap is. Just gonna add it to my git ignore. Guessing these are window files that I don't care about. Cool. Deleted. Sick. Okay. Cool. Oh, no, we wanted it. Did I just delete it? No, still there. Okay. Write to file. And last up, before we print out a test, oh man, I'm going to take just a quick second to stand up and stretch. Cool. So, let's think about how we want to do new lines. So let's open up our trusty paint. And let's go look at our main code. To this point, let's give this a better name. Sweet. Okay. So, each time we draw a character, we give it this spacing after the character's done. And so, come in here, and if we're doing hello world, so hello world, cool. We will come in, if we want to do just some little boxes, 2, 3, 4, 5. Cool. So you come in, let's change colors. We draw our H, we draw our E, and also we added a little bit in of spacing. So there's a little bit of space between each letter so they don't overlap. L, L, O, and such. So imagine our width, oh, was the letter W? I think it was like that. Looks like a smiley face. So assume our printer can only print 6 characters across. We need to somehow get to the next line. So if we define the printer width, black. So make our printer width that, come back in blue. We want a way to go the next line. And then finish out, actually that should have been a space, whoops, oh well. O, R, L, D. And so we have this, which should be our printer height. So we see in some way when we get to here, we want to reset the X, increase the Y, and then keep going. Cool. Okay, so seems pretty reasonable. All right, so we probably want Y start we want some constants. We want our X start it's like a min X. It needs to be constants. Printer, let's declare these above. So constants usually go at the top of the file after imports. So max X equals and min so we already know that we checked that the valid kind of starting points are 150 and 20. Alright, so let's think about our maxes here. So we come over here and we want to move. So first let's home the X and the Y. Is it already home? I think it's already home. Cool. So it's squares. Let's see. So 8, 9, 10. I think it's 15. So we said, I think 150. Yeah, makes sense. What if we go to 160? 160 would work. And then the min Y. 0 works, actually. Cool. And then from there, we can go, I think it's 200 for the Y. So that's 100, 10, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 220. And now we can go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150. Right, that would make sense. This would be 0. Okay. So we could probably fix these coordinates to make them that, min Y is less than max Y, but here it's kind of the other way around. But for now, let's keep going with it. Okay. So we start out, we'll start out at min X, and we'll start out at min Y. So at any point, if X start is if X start plus this business, we should probably put these in some kind of const. Call it like amplitude, right? That could be a good word. It's kind of like the Oh no, it's the period. Period is what we want. The interval of time between successive occurrences of the same state. Yes. So let's call this the x period. Cool. And while we're at it, we could define the y period as the y spacing. Cool. Y is a bit greater, so this will actually be 1. Okay. So basically it's here if the x start minus the x period is, this math's gonna mess me up. And then y start plus equal y period. Okay, so what that says, if so x start is going to start at, let's split this. Okay. Oh, wrong way. Okay, so our x start is going to start at 160. Our y start's going to start at 0. So if 160 minus our period, so this is going to keep getting smaller towards 0. And eventually this is going to be less than 0. So let's say this is like -10 and this is 0. So if it's less than, we've moved off the bed and we want to come back and go back to our starting position, which is our min x again, and our y start will now increase by that period that we specified. So we also want to check this for in the, we also need a parenthesis here. Let's do that, makes it more legible. We want to do the same thing I think we max out the y, we just want to end. So if y start plus y period is greater than max y. I'm going to do a quick tangent because I know I want to cool. Okay. So if y start plus y period is greater than max y, so right here we've just, actually we don't even need this because we've already incremented y. So if y start is greater, we just don't printing, and that should stop. Oh, so this will actually catch. So I made some comments before and I realized that I was thinking that this script was going to run and like errors were going to happen. So like, to give a better example, this is kind of hard to explain, to be honest. If I throw in a whole ton of characters, this function will actually fail as I try and generate G-code, is basically what I'm getting at. So if we come in here and make this just excessive, very excessive, I believe if we run this, it should throw an error saying that we've exceeded the printing bed. Cool. So really we get all this nice checking before we even load the G code in. So this function will this exception will raise when we run the Python, and the Python's super fast. So cool. And then we can come in here and we can look at our output, which happened just now, and it looks good. Okay. So, out of curiosity, if we load this up a few times, let's see. At some point, let's run that again. Let's look at our new output. I want to see that it goes to a new line. So we're always on the same kind of between y10, y20, y0. So at some point it should switch to being a bit greater than y10, y20. Yep, here it is. So increases. What if we'll get to 3 lines? We do get to 3 lines. Okay, cool. So let's write a test function, or a test, to see. I think we're kind of done. Support new lines. I think it's done. Finish numbers and letters is kind of done. Okay, so if we do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. I want to do the same thing, but uppercase. And then I want to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, underscore dash, because I believe that's our whole alphabet. So if we run this, works, we get some output G code. Oh my gosh, how many lines is it? Oh, that's insane. 1,500 lines of G code. Oh, this is very cool. Okay, so I don't have any large sheets of paper to test this out on. Shit. Man. I could like rip apart a notebook. Alright. Give me 1 sec. I will be right back as I go and scavenge. Alright, so I've come up with this cardboard. I think the cardboard will be a bit more forgiving. I realize I've even just tested, done a little line there, and even if you drag the pen pretty hard into the surface of the cardboard, it's still pretty forgiving. So, I want to cut this bad boy to size. So we want an area that is 160 by 220. Cool. So if we measure from the top, 160. Let's go a little bit more. 160 by 230. Cool. I'm refinishing this desk, so I don't really care if I mess it up. Yeah, man. There we go. Cool. Alright. So this is our printing area. let's go test out that this fits. So if we home these, and we want to move the X over by 100, and then move it over 1, 2, 3, 4, 5, 6. This is our starting point for our pen. So if we grab our pen out, pop it in here. Cool. And if we move our Z up, oh, wrong way. Okay, let's home the Z and figure out a good height for this cardboard. Okay, let's see. Okay, so it's not there. Alright, so we'll move it up. 1, 2, 3. Okay, that Y is a little too close to the edge. So if we go down 1, 2, 3, 4, 5, 6, 10. Yeah, that's a better starting point. So, alright, so we're at Y10. Gonna get out my trusty clamps. Ooh. Cool. Oh, totally just borked the camera. Sorry, folks. This camera tends to shut down. It's not even streaming in real time, whatever. Okay. That's pretty in there. Alright, let's home the Z real quick, because that Z... Okay, it's not good. So if we go down now by ones... Okay, just so I can click this. So that's at 5. Okay. So... This is so finicky. Oh, I said 10. And it's not even drawing. Oh, frick. I should put my glasses on. I can't see anything. Okay. Let's just move this. I can't move it that way. Okay. This one's 0.1s. Okay. I don't even know what Z I'm at right now. Okay, so that's 0. 1, 2, 3. 4, 5. 4.5. 4.5. Let's go 4.6, 4.7, 4.8. Okay, I'm going backwards with these. Okay, so that should be 4.8. 4.8. Okay. All right, so let's try this again. So if I go 1, 2, 3, 4, 5, 4.8. This is, I feel like a pen was not the best for this. I might need to do this for a marker. Okay. Let's just go wild and see what happens as I try and draw. Anyway, so let's bring our pen up, retract this. Let's go to our home on the X and Y. Let's see if we went too ambitious with our max Y. So max Y is 220. 100, 200. Heh. Oh, sorry, that's your max X. Or max Y is this way. 100, 200. Yeah, let's set our max Y a little less. Let's go like 100 for now. Cool. Okay. Cool. Okay. Let's generate some pretty good. Okay. Let's see what happens. Can I read timestamps? 2:18. That is now. All right. Fingers crossed. I'm gonna film this with my camera. Here goes nothing. Yeah, let's see what happens. It kind of works. Ah, this is pretty sick. All right, what are the chances I totally didn't just mess up the? Sorry, mess up the go to the next line. We are currently on. Don't even know what letter we're on. I don't even know what letter of the alphabet we're on. T-U-O-V W X Y Z. Cool. All right, so now it's going to repeat the alphabet again because I had to go and unfortunately put that first as uppercase, but then we'll get to the numbers. But it looks like New Lines is just chugging along. We're on the letter D right now. this is sick. This is so sick. Cool. What letter of the alphabet are on? We are on O. Yes. P. Cool. We are probably, judging by this, halfway done? 2/3 the way done? Printing our test. Sick. Okay. Here comes X, Y. Terrible looking Z. 1, 2. Nice. Oh man. I've wanted to build a 2D plotter for 7 years now. 7 years. And it's done. I really should not home at the end. There we go. All right. Here we go. Oh my god, this is so cool. Okay, so let's see. 2, 2, 2. So as you can see, 1, 2, 3 along the bottom. Where's my finger? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you kind of got the rest of the alphabet in there. Let's enlarge this a little bit. So yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Zero's kind of off. I didn't quite position the cardboard that well, but sick. All right, so I think observations I'm making, if you look closely, you can see that there's a lot of X's in the various places. So like right there, there's an X, 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 X. And that's because I did not set my travel height. Let's see. 4.8, the difference between 4.8 and 6 is 1.2 millimeters, which is, I can't even get it on this caliper, is that's very small. So I set that travel height a little bit too high, or a little bit too low, I should say. I think with the fact that, like this cardboard itself, like what's the thickness of this cardboard? This cardboard is 3 millimeters thick at its thickest, and then at its thinnest, where you kind of have those creases, it's like down to 1.5. So that's a difference of 1.5, which is already greater than our height of drawing and traveling. Kind of too much inconsistencies, like these little valleys in here. I also think I need to design a new part because I don't know. A pen head is a little bit too hard, and I'd be down to destroy one of these markers. Chances this marker just fits. Nope, and I totally just broke my just broke the plastic piece off that holds the pen in place. So yeah, I'm gonna need to design a new part. Which, hey, now you guys get to see how I design parts. So, boom. Put those calipers away. Let's take a peek at our README. We exported new lines, finish numbers and letters. Let's go look at our code, see how we like it. Don't need this bottom anymore. Let's get rid of this monstrosity. Let's make it a simple collection. A, B, C, D, E, F, 1, 2, 3, 4, 5. A little simple test string. So looking at, let's see, so next steps, figure out travel height. Design new pen holder. Probably want a pen holder that's a little bit more accepting of various types of drawing utensils. So if I peek at what I have, so like, man, I live a little bit minimally, so I actually really don't have a variety of pens. And I actually like all my pens and markers and stuff. But it's probably going to be a dry erase board that ends up taking the hit. But so we come look at the fourth iteration. I was kind of onto something here with this design that I could run a binder clip between this wall and kind of clamp down on the pen. So make this little area in here a little bit more accepting of pens of different diameters. So how can we hold both this, and that? Well, I should get rid of my giant ass video. Sorry, so to repeat that, this wall and that wall, put a binder clip, and then be able to accept different kinds of pens. So if we can make this little diameter here a little bit more accepting, that'd be a good way to go. Because I keep snapping off this wall here. Cool. So back in code, design new pen holder to accept sizes, figure out the travel and draw height. Cool. I'm also wondering if the spacing between vertically and horizontally between those letters is enough. It feels like enough. Oh, we also didn't try and test out printing spaces. Cool. All right, I think that will be about all for now. I think this will be the first task next time. So we can kind of do this, and then we can code all these other bits while this design's printing out. So I'll probably be back a little bit later today to take another tackle at this, but for now I need to go get some food and relax. So thanks for watching, and we'll be back another time. And I didn't hit the start record button.